A PLC decides to extend a cylinder, then retract it. But the PLC output is a tiny electrical signal. It cannot move air. So how does that one signal flip a pneumatic cylinder back and forth? The answer is a spool valve. A spool slides inside a body and reroutes compressed air to whichever side of the cylinder needs it. In this video, I will explain what a spool valve actually is, what those numbers like 5-2 and 3-2 mean, how the spool gets shifted, and exactly how a PLC drives the solenoid that moves it. Let us start with the part. Quick note before we dig in. This is from PLC Simulator, where you can practice automation and motion, and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the valve. So what is a spool valve, really? It is a directional control valve. Its whole job is to decide where the air goes. Inside the valve body is a precision machine spool, a cylinder with fat sections and narrow necks along its length. That spool slides back and forth inside a board housing. The fat sections are called lands. They block. The narrow necks let air pass around them. As the spool shifts, those lands and necks line up with different ports drilled into the body. So in one position, the valve connects supply to one side of a cylinder and vents the other side. Slide the spool across, and it swaps. Now supply feeds the opposite side, and the first side vents. Same valve, same air, completely different path. That is the trick. Move the spool, change the direction. Now the notation that trips everyone up. You will see valves labeled 5-2, 4-2, 3-2. It is two numbers. The first number is the count of ports, the working air connections on the valve. The second number is the count of positions, the distinct states the spool can sit in. So a 5-2 valve has 5 ports and 2 positions. That is the workhorse for a double-acting cylinder, one that is powered both extending and retracting. A 4-2 does a similar job with 4 ports. And a 3-2 valve has 3 ports and 2 positions. That is the standard for a single-acting cylinder or any simple on and off air job. So read it as ports first, position second. 5-2. 5 ports, 2 positions. So what actually moves the spool? Something has to push it. The most common is a solenoid, an electric coil that, when energized, shoves the spool to one end. You also get pilot valves, where a small burst of air does the pushing and plain manual levers and buttons. Then there is the question of how it comes back. 2 styles. Spring return. A spring sits at one end, so the moment you stop driving the spool, the spring snaps it back to its rest position, or détente. The valve holds whichever position it was last shifted to and just stays there until something shifts it the other way. Spring return is the simplest. Détente remembers. Now the part that matters for programming. How does the PLC drive this? For on and off direction, the PLC uses a digital output. It energizes the solenoid coil. The coil shifts the spool, and the air reroutes. The cylinder moves. One bit on or off. Here is the important wiring distinction. A single solenoid valve usually has one coil and a return spring. The PLC must hold that output on to keep the spool shifted. Drop the output, the spring returns it. A double solenoid valve has a coil at each end and no spring. It latches. So the PLC only needs to pulse one coil to shift it, then a pulse to the other coil to shift it back. Single solenoid, hold the output. Double solenoid, pulse it. The spool valve drives the actuator, and I cover the actuator itself in the linked What is an Actuator video. So here's what to walk away with. A spool valve is a directional control valve. A spool slides inside a body and reroutes air to flip a cylinder's direction. The numbers are ports first, position second. 5-2 for a double-acting cylinder, 3-2 for single-acting. A solenoid, a pilot, or a lever shifts the spool, and it is either spring return or détente. And a PLC drives it with a digital output to the solenoid coil. Get that, and every pneumatic schematic on the floor stops being a mystery. Now go make it concrete. If you want to practice automation and motion hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.